Okay, so this video is covering all the questions involving circumferences and areas of circles. Okay, remember you can find all the PDFs for these questions on mathsupgrade.co.uk. Okay, so this first question involves 4 diagrams and 4 words. You have to match the diagram with the correct word. Okay, so you draw an arrow from each one to its mathematical word. So here's the solutions for this question here. Okay, remember a diameter is from edge to edge straight through the middle. So that's a distance from edge to edge straight through the middle. So that's the diameter there. Okay, the radius is half the diameter. So from the center to the edge, so there's the radius. A chord is similar to a diameter, but it doesn't go through the middle. So there's a chord there. The tangent, okay, is a line which just touches the edge of the circle. Just touches the edge of the circle, straight line. So there's the tangent there. So that is 2 marks for that question. So this question is worth 2 marks, and you have to draw a diameter of a circle and then draw a segment of a circle. Okay, so remember a diameter of a circle is a line which goes from edge to edge straight through the middle. So there's a diameter there. Okay, should be a straight line using the ruler. And the second part of the question, a segment of a circle is similar to a diameter, but it doesn't go through the middle, and it's the area between that straight line and the edge of the circle. Okay, so there's a segment of a circle. Okay, I've shaded in here a minor segment. I could have shaded in the major segment here. Okay, that doesn't make a difference, but that is a segment of a circle. It's the region between that line there, which is the chord, and the edge of the circle there. That is 2 marks. Okay, question 3. You have to draw a chord of this circle. Okay, a chord of a circle is quite simply a line which goes from edge to edge but not through the middle. So a chord of a circle is simply a line like that, and that is 1 mark. Make sure you use a ruler and a pencil to draw a straight line. Okay, question 4. So it states that the line OP is a radius of a circle with the center O. So imagine this is the center of a circle here at O. You've got to draw a circle accurately. So my advice here would be make sure you use compasses. Okay, put the center of the compass there, the sharp point there, the edge of the compass with a pencil would be there. So make sure it's that wide, and then the circle would be all the way around here, a nice smooth circle. Okay, that is worth 1 mark. The second part of this question. Okay, part B, you have to draw a chord. Okay, so draw a chord here. Again, use a pencil, and this time use a ruler, and a chord goes from edge to edge, okay, but not through the middle. So a chord would be something like that. So the whole question there is 2 marks. Okay, question 5, you're given a circle, and in part A, you have to measure the diameter of the circle. So remember, the diameter is a distance from one edge of the circle to the opposite edge of the circle, but straight through the middle. So make sure you use a ruler and measure really accurately from edge to edge straight through the middle. Depends on how it's printed for you, but if you print it in A4, okay, you'd get 5 centimeters for that diameter. And then part B. Part B, in the sector below, draw a in the circle below, draw a sector. You have to shade your sector. So a sector is a region which is formed with 2 radii, two radiuses, okay, and you'd get something like this. Okay, make sure you use a ruler and a pencil, and then shade your sector afterwards. Part C, write down the mathematical name of the straight line shown in the diagram below. So this line here is called a chord. That's a chord. Okay, so make sure you spell it correctly, and you'll get that mark. Overall, the whole question is worth 3 marks. Okay, in question 6, you're shown a circle with 2 straight lines. Okay, the straight line inside the circle goes through the center of the circle. Write down the mathematical name of that straight line for 1 mark. So that line there, because it's going from edge to edge straight through the middle, it's called a diameter. Okay, so make sure you spell that word right, diameter there. Okay, and the second line, okay, it's outside the circle, but it just touches the circle at one point. Okay, write down the mathematical name of that line. So that line there is called a tangent. Okay, again, spell it correctly. And in part C, Okay, is a different circle, center O, draw a sector of the circle. A sector is a region which is formed between that radius and another radius. You can draw it anywhere you want to, and it's that region there. Okay, so it's formed between the two radii and the edge of the circle there. Okay, so make sure you shade it in, and obviously using a pencil, and it'll get that mark there. So overall that question is worth 3 marks. Okay, question 7. Bellina has a garden in the shape of a circle of radius 10 meters. He's going to cover the garden with grass seed to make a lawn. Okay, so straight away, if he's covering the garden, he's covering that region there. So this question will involve area. Okay, so the grass seed is sold in boxes. Each box of grass seed will cover 46 meters squared of garden. Okay, that's per box. You want to cover all of the garden with grass seed. Work out an estimate for the number of boxes of grass seed Bellina needs. You must show your working. So in this question, I would underline that word cover, because that means an area. The radius is important, so I'd underline that section there. Okay, and remember you're given this measurement here. Okay, so this is the radius. Okay, so I'd make a note of that as the radius. Okay, and so in this question, what I'm going to do is I'm also going to underline this word here, estimate. Okay, I need to work out an estimate. The reason I'm estimating is because this question involves area, and the formula for area involves pi, but this is a non-calculated question. So when I'm estimating, I'm going to use the value of pi as being 3. So this is how I'm going to do the question. First of all, let's find the area. Well, the area, formula for area is pi r squared. Okay, and so the radius is 10, so 10 squared times by pi, which I'm rounding to just 3, I'll get 300. Okay, so the area is 300. The next part, I need to work out how many boxes I need. Okay, well, one box covers 46 meters squared. Because it's an estimation question as well, I'm going to round this 46 meters squared to just one significant figure. So this would be 50. So the number of boxes I need is the area of the whole garden, which is 300, divided by the coverage per box, which is 50. So 300 divided by 50 would give me 6 boxes. 6 boxes. So that is 4 marks there for that question. Okay, the next part of the question, it says, is your estimate for part A, is it an underestimate or is it an overestimate? Give a reason for your answer. Okay, well, remember in this question here, what I've done is I've rounded pi slightly down, because the real value of pi is 3.14. So I've rounded it slightly down, and also the coverage per box I've rounded up. So my area is slightly lower than what it should be in real life, and my coverage per box is slightly higher than what it should be in real life. So I've divided a slightly smaller value by a slightly larger value. Okay, so my answer is an underestimate. My answer is an underestimate. Okay, and here's my reasoning in words there. My answer is an underestimate as the area was rounded down and the coverage per box was rounded up. Okay, so that whole question there is worth 5 marks. Okay, question 8. I'm given a circle inside a square. Okay, so this is a square, even though it's slightly diagonal, it is still a square. It's got a side of 10 centimeters. Each side of the square is a tangent to the circle. So what that means is this side of the square here is just touching the edge of the circle at just one point. Similarly all the way around. Okay, work out the total area of the shaded regions in terms of pi. Give your answer in its simplest form. Okay, I'm asked to work out the total area in terms of pi because it's a non-calculated question. Okay, so you need to find the total area of the shaded regions, which are these 4 sections here. So the total area of these 4 sections in terms of pi. Okay, so the way I'm going to do this is I'm going to find the area of the square, because I know one length of the square. I'm going to find the area of the circle, because I know the diameter of the circle, so therefore I can find the radius of the circle. Then I'm going to subtract those 2 areas to give me the area of the shaded sections. Okay, so this is how I'm going to do it. First of all, the area of the square is just the length of the square times by itself squared. So it's 10 squared. Okay, which is 100. The area of the circle is given by this formula, pi r squared. Well, the radius isn't 10, the radius is half of that because that's the diameter, so the radius is 5, so pi times 5 squared. Pi times 5 squared is 25 pi. So the area of the shaded section is the area of the square subtract the area of the circle, because the circle's been cut out of the square. So that's 100 minus 25 pi. So that question there is 3 marks. Okay, question 9. The diagram shows a circle drawn inside a square. Okay, similar to the last question. Circle drawn inside a square. The circle's got a radius of 6. Okay, and the square's got a side of length 12. Work out the shaded area. Give your answer in terms of pi. So very similar to the last question, although here it's only one section which is shaded here, not all of them, just one section here. Okay, so this question, very similar to the last one. Okay, I'm going to make note of the fact that this radius is 6. Okay, the length of the side is 12. The length of the square is 12. So to find the shaded area, this area here, I'm going to find the area of the square. I'm going to subtract from that the area of the circle, and then because it's one shaded section out of these four sections altogether, I'm going to divide the answer by 4. Okay, so it's very similar to the last question. Okay, so let's find the area of the square. Well, that's going to be 12 squared. 12 times 12, which is 144. The area of the circle is going to be pi r squared. Pi times 6 squared, which is 36 pi. Okay, so when I subtract those two, 144 subtract 36 pi, I'm left with the area of this corner, the area of this corner, and this corner, and this corner. Well, I only need one of them, and because they're identical and there's 4 of them, I can divide that by 4. Okay, so if I simplify that, that gives me 144 divided by 4 is 36. 36 pi divided by 4 is 9 pi. So 36 minus 9 pi. I have to leave my answer in terms of pi because it's a non-calculated question. Okay, but that would give you 3 marks. Okay, question 10. The diagram shows a logo made from 3 circles. Each circle has a center O. So these are called concentric circles because they've got a common center. Concentric circles, okay? Daisy says that exactly 1/3 of the logo is shaded. Is she correct? 1/3 of the logo. Okay, you can see why she may say that, because you've essentially got 3 sections here and one of them is shaded. But are all 3 sections the same area? Okay, that's what we need to find out. So we're going to approach this question. I'm going to find the area of each of these sections. Okay, and then I'm going to find the proportion of the shaded section divided by the whole amount, and then I'm going to prove whether she's right or wrong. Okay, so let's do that now. So first of all, I'm going to find the area of this medium circle, the medium circle, okay, the whole of the medium circle. Well, the area of a circle is given by pi r squared. So that's pi times 7 squared, because the radius of this whole purple circle, imagine if it's all shaded, is 7. So pi times 7 squared, 49 pi. The area of this inner circle here, the white section here, okay, is pi times radius squared, pi times 4 squared, which is 16 pi. Okay, now I'm now going to find the area of the shaded part only, because here I found the area of the medium circle. Let's find the area of that shaded ring. The area of the shaded ring is the area of the medium circle, the purple circle there, subtract that inner circle. So that's 49 pi, subtract 16 pi, which gives me 33 pi. Okay, I'm leaving this all in terms of pi, okay, because I don't want to work with decimals here, and that pi should all cancel out. So that's 33 pi. Now, let's find the area of the whole amount. So the whole amount here, okay, the whole circle. Well, that's going to be pi times radius squared, pi times 4, add 3, add 3, that's 10. So radius is 10, so pi times 10 squared, which is 100 pi. So the area of the whole amount is 100 pi. So now, Daisy said that exactly 1/3 of that logo is shaded. Okay, 1/3. Well, here's a shaded amount, 33 pi. Here's the whole amount, 100 pi. Let's divide these two through here and see what we get. 33 pi divided by 100 pi. Look what's happened. The pi's cancel. and I can't cancel this anymore, I can't simplify the fraction anymore, 33 over 100 is my exact proportion of the shaded logo. Okay, so is she correct? She said exactly 1/3 is shaded. Is 33 over 100 exactly 1/3? Well, it's not exactly 1/3, so therefore she's not correct. And I've given it there as decimals as well. 33 over 100 is exactly 0.33. 1/3 is 0.3 recurring, 0.33333, and it carries on. So these two are not exactly equal. So she's not correct. Okay? Because of this word here, it says exactly 1/3 is shaded. So that whole question is worth 4 marks. Okay, question 11. This time a calculator is allowed in these questions now. The circle's got a diameter of 140 centimeters. Work out the circumference of the circle. Give your answer correct to 3 significant figures. Okay, well, this question, what I'm going to do, I'm going to underline this 140 on the diameter. Okay, I'm going to underline that word circumference, and I'm going to underline 3 significant figures. Okay, so I've got to find circumference, and that's given by a formula C equals pi d. So C equals pi times diameter, so pi times 140 would give me 439.8. Okay, so that's the 4 significant figures. Okay, but when I round it to 3 significant figures, I'll get 440. Okay, because this rounds slightly up because of this digit here. This digit rounds up, so this becomes 440 centimeters. Okay, that's 2 marks for that question. Okay, question 12. This circle has a radius of 5.8 centimeters. Work out the area of the circle, giving your answer to 1 decimal place. So quite simply, this question, I'd underline radius of 5.8, I'd underline the word area, and underline 1 decimal place. So for this question, try and find the area. That's given by a formula A equals pi r squared, circles. So area is pi times radius squared. Okay, so the radius is 5.8. I'll square that with a calculator, multiply by pi. Okay, I get 105.68. And then when I round this to 1 decimal place, I'll get 105.7 centimeters squared. Let's just check this is centimeters. So that would be centimeters squared, and that's 2 marks. Question 13. I'm given a circle. Again, the diagram's not accurately drawn. The diameter is 9 centimeters, so that's a distance from edge to edge straight through the middle. Work out the circumference of the circle. Give your answer to 3 significant figures. So for this question, I'd underline the word diameter, underline 9 centimeters, and underline that word circumference. I'm going to give my answer correct to 3 significant figures. So quite simply, I'm going to use this formula. Circumference is pi times diameter. C equals pi d. So that'll give me pi times 9, which is 28.27. When I round that number to 3 significant figures, I'll get 28.3 centimeters. Let's just check. This is centimeters, that's centimeters, so that's fine. 2 marks. Okay, question 14. So Susan has a round cake. The cake has a diameter of 20 centimeters. So that's from edge to edge, straight through the middle. Susan wants to put a ribbon around the cake. What's the least length of ribbon she can use? Okay, so without any overlapping, how much ribbon will she need? So with this question, underline the word diameter in 20 centimeters. Okay, if you're going to put it round the cake, that involves circumference. Okay, and the least length, so you can assume there's no overlapping. So I'm going to use the formula C equals pi d to find the circumference. Essentially, I need to find the circumference of the cake. C equals pi d would give me pi times 20 centimeters, which is 62.83. Okay, so 62.8 centimeters is the least length of ribbon that she needs. Okay, and that would be 3 marks. So question 15, I'm showing the surface of a pond which is in the shape of a circle. So it's like a plan view of that pond. The circle has got a radius of 120 centimeters. So from the edge to the center is 120 centimeters. Mark wants to put 20 fish into the pond. There needs to be a surface area of 1,800 centimeters squared per fish. Okay, so for each fish, that's how much area it needs. Show that the surface of the pond is large enough for Mark to put 20 fish into the pond. So in this question, I'd underline 120 centimeters as the radius. I'd underline 20 fish. And I'd underline this information here about the surface area of 1,800 centimeters squared per fish. Okay, so I'm going to do this question by, first of all, finding the area of the whole pond. Okay, then I'm going to work out the area that I'll get for each fish. So I'm going to divide the area by the number of fish. Let's do that now. Okay, so let's find the area first. So the area is given by pi r squared. So pi times 120 squared, which is 45,238.9. Okay, so that's the area of the whole pond. It seems like a big number, but remember it's in centimeters squared. Okay, so it's centimeters squared. Now the area that each fish will get on average is the area of the whole pond divided by the number of fish. So if it's putting 20 fish into the pond, it'll be 45,000 divided by 20, which is 2,261.9. Okay, per fish. So is that bigger than 1,800? Well, yes, it is bigger than 1,800. So the fund is large enough for all those 20 fish. 4 marks for that question. Question 16. I've given a diagram which shows a flower bed in the shape of a circle. The flower bed has got a diameter of 2.4 meters. So that means that the distance from edge to edge, straight through the middle, is 2.4 meters. Sue's going to put a plastic strip around the edge of the flower bed. So a plastic strip all the way around here. The plastic strip is sold in 2-meter rolls. How many rolls of plastic strip does she need to buy? You must show while you're working. Okay, so in this question, I'm going to underline this 2.4 meters. Okay, I'm going to underline the fact that the strip is sold in 2-meter rolls. And I need to work out how many rolls she needs, showing all my work. So this question, because she's putting it around the edge of the flower bed, so imagine this is a plan view of the flower bed. Okay, she's putting it around the edge. Well, the edge of a circle is called the circumference. So I need to work out the circumference of this circle. Once I found the circumference of the circle, I can then divide it by the length of one strip, so divide it by 2, and that will then give me how many rolls I need to buy. Okay, so let's do that now. So I've underlined the important sections. I'm quoting the formula here. I'm substituting in for diameter of 2.4, using a calculator to work that out. Now let's find the number of strips. So let's do that circumference divided by the length of each strip, which gives me 3.769. So Sue will need 3.769 strips, right? 3.769 rolls. But she cannot buy 3.769 rolls. She has to buy either 3 rolls or 4 rolls. If she buys 3 rolls, she won't have enough. So she has to buy 4 rolls, and she'll have some of that plastic strip left over. That whole question there is worth 4 marks. Question 17. John has got a flower garden in the shape of a circle. Okay, so again, this is a plan view of that garden. Okay, the diameter of the garden is 5 meters. He wants to put fencing around the edge of the garden. So I want to put around the edge of the garden. So this question will involve circumference. The fencing costs £1.80 per meter. Work out the total cost of the fencing. Okay, so the perimeter of the garden is the circumference all the way around. Okay, so to find the circumference, I'm going to use the formula C equals pi d. Okay, so C equals pi d. So pi times the diameter, which gives me 15.708 meters. So that's the distance all the way around that garden. Now, since fencing is sold per meter, I'm going to round this up to 16. Okay, 16. Okay, because otherwise I cannot buy 15.7 meters of fencing. It's sold per meter because it costs per meter. Okay, so now I need 16 meters of fencing. The total cost is going to be 16 times by £1.80. 16 times 1.8 gives me £28.80 for 3 marks. Okay, question 18. So Mr. Weaver's garden is in the shape of a rectangle. Okay, as you can see there, a plan view of that garden. Okay, quite a complicated garden. He's got a patio in the shape of a rectangle here. Okay, and he's got 2 ponds here. Okay, the circles, they've each got a diameter of 3.8, so they're identical circles. Okay, the rest of the garden, all this shaded region is grass, and he's going to spread fertilizer all over the grass. 1 box of fertilizer will cover 25 meters squared of grass. How many boxes of fertilizer does he need? Okay, and I've got to show all my working. So first of all, I'm going to underline, I'll start on that text, I'm going to underline all the important information. Okay, the fact he's got 2 ponds, diameter 3.8. Okay, and I've even here marked the fact that the radius is going to be 1.9 because the radius is half the diameter. Okay, and also I've underlined the fact that he needs fertilizer. 1 box will cover 25 meters squared. So the first thing I'm going to do in this question is I'm going to find the area of that rectangle there. So the area of this rectangle, okay, I need the length of the rectangle and the width of the rectangle. Well, the width is given to me as 9.5, but the length is going to be 17 minus 2.8 because they're both horizontal lengths. So 17 minus 2.8 would give me 14.2. So to find the area of this whole rectangle here, I'm going to do 14.2 times 9.5. Okay, so length times width, which gives me 134.9. So that's the area of the grass rectangle. Okay, but to find the area of just the grass, I need to subtract the areas of the ponds because these ponds have been cut out from that grass. Let's find the area of each pond. Well, the pond is in the shape of a circle. So if we can use the formula for the area of a circle, then we can find the area of each pond. The area for circle is pi r squared. So pi times 1.9 squared, which is 11.34. Remember, I'm using 1.9 because that's the radius there. I shouldn't use a diameter for area, should use the radius, okay? Now, to find the area of the shaded region here, the area of the shaded region, right, so the grass, well, that's going to be the area of the rectangle found earlier here, 134.9, subtract 2 lots of ponds. Okay, so subtract 2 lots of ponds. That's 134.9 minus 11.34 minus another 11.34, which leaves me 112.2. So that's the area of the grass, 112.2. Now, to find the number of boxes of fertilizer, well, each box of fertilizer covers 25 meters squared. So 1 box would cover 25 meters squared, 2 boxes would cover 50, and so on and so forth. So if I divide the area of grass by the coverage per box, that leaves me with how many boxes he'll need. Okay, so he'll need 4.48 boxes. 4.48 boxes. Well, he cannot buy 4.48 boxes. He can either buy 4 boxes or 5 boxes. He has to buy 5 boxes, and obviously then he'll have a little bit left over. Okay, so the whole question there is worth 5 marks. Okay, question 19. Okay, this is a 4-mark question, and it involves not only the area of a circle, but also Pythagoras. Okay, so I'm told that a square with sides of length x is inside a circle. Each corner of the square is on the circumference of the circle, and the area of the circle is given to me as 49. Work out the length of each side of that square. So work out the value of x to 3 significant figures. So I'm just going to set up a diagram first of all. So here's my diagram. Here's a circle. There's a square inside the circle with each corner, each vertex of that square just touching the edge of the circle. Okay. Now I also know for any square, the diagonals of the square meet at a right angle. So this diagonal with this diagonal meet at a right angle. I also know, because this is a diagonal of the square and the square just touches the edge of the circle, this must be the center of the circle here. So that distance from the center to the edge is the radius. So this is the radius, that's the radius. So label them as r there. The other thing I'm labeling in this diagram is x, because the sides of the square are of length x. So that's x there. Now, let's just park that diagram for now. Let's see if we can work out the radius of the circle. If I know that the area is given as 49, I now need to work backwards from this formula to find the radius. So let's rearrange this formula to get the radius as the subject of that formula. So I'm going to divide both sides by pi and do the inverse of squaring, which is square rooting. So divide both sides by pi, I'll get a over pi, and then square root, and then I get that there, which represents the radius. So now, if I substitute 49 for the area and divide by pi and square root, the radius is given as 3.949. So now, let's look back at this diagram. Okay, I now know that the radius is 3.949. Okay, so let's redraw it here. 3.949, 3.949. So these two sides are equal because they're both radii. So it's an isosceles triangle, and it's a right-angled isosceles triangle. Okay. Now, because it's a right-angled triangle, I know that I can use Pythagoras or trigonometry. Okay. I'm going to use Pythagoras since I need to work out the length of this side here. This is the longest side, okay, otherwise known as the hypotenuse. To find the length of that longest side, I use Pythagoras. Pythagoras states that the sum of the squares on the two shorter sides is equal to the square, the area of the square, on the longest side, on the hypotenuse. Okay, so quite simply, if I square this number, add those two values together, and then if I square root, I end up with the value for x. Okay. If that's difficult for you, look at Pythagoras on my website, okay, and on this channel, and that should make it slightly easier for you. Essentially, I get a value of x of 5.5851. If I round that to three significant figures, I get 5.59, and that will be in centimeters. So make sure you quote that unit as well. The whole question there is worth 4 marks. Okay, question 20. Sophia is organising a conference. People at the conference will sit at circular tables. Okay, so each table has a diameter of 140 centimeters. Each person needs 60 centimeters around the circumference of the table. And there's 12 of those tables in the conference room. A total of 90 people will be at the conference. Are there enough tables in that conference room? So in this question, there's a lot of information there, a lot of numbers there, okay? Quite simply, okay, this question involves circumference, and it's even given in that statement there, okay? So I need to use the formula C equals pi d. I'm going to use that formula to find the circumference of the table from that diameter. So you use C equals pi d. When I find circumference, I'm then going to divide that by the amount of space each person needs, okay, to see how many people can sit around each table. And then I'm going to multiply that by the number of tables to see if that's enough for 90 people. So let's do that now. So here's my information underlined. Okay, first of all, I'm going to find the circumference of the table. So that's pi times diameter. So I'm going to do pi times 140 centimeters. That gives me the circumference of one table, which is 439.82. Okay, now to work out how many people can sit around that one table, okay, I'm going to divide that circumference by the amount of space each person needs. So one person needs 60 centimeters. So let's do the circumference I've just worked out, divide that by 60, because they're both in centimeters. That gives me now 7.33. So that's not quite enough space for 8 people. Okay, so I'm going to round this down. Okay, so on each table, 7 people can sit comfortably. There'll be a little bit of space left over, but 7 people will sit comfortably. 8 people won't quite be able to sit with enough space. So there's 7 people per table, and there's 12 tables. 7 times 12, the maximum number of people would be 84. Okay, so are there enough tables? Well, she needs 90 people at the conference, so she'll need one more table, and one more table will be enough. Okay, because 7 times 13 would give you 91. Okay, so one more table, otherwise 6 people will be standing. So the whole question there is worth 4 marks. Okay, question 21. A garden is in the shape of a rectangle, ABCD, and a semicircle. AD is the diameter of the semicircle. Carol is going to cover the garden with fertilizer. A box of fertilizer costs £4.99. Carol's been told that one box of fertilizer will cover 12 meters squared of garden. Work out the cost of buying enough fertilizer to cover the garden completely. So this question involves area, because you're covering a region. Okay, so it involves area. So what I'm going to do is I'm going to find the whole area of that entire shape. It's a compound shape involving a rectangle and a semicircle. And find the whole area. Then I'm going to find the number of boxes I need by dividing the area by the coverage per box. Okay, and then I'm going to multiply that by the cost per box to find the total cost. So let's underline the key information in this diagram. Okay, so here's the key information underlined. Now, what I'm going to do first of all is I'm going to find the area of this rectangle here. And that's straightforward because I'm given the length and I'm given the width. So multiply those two together to get the area of the rectangle. That's 47.04. Now to find the area of this top section, okay, of that garden, to find the area of the top section, well, that top section is a semicircle, okay? So the area of a semicircle is just half the area of a circle. So it's pi r squared and divided by 2. Be careful here because the radius is not 8.4, the radius is half that, so the radius is 4.2. So pi times 4.2 squared divided by 2 gives me 27.71. So that is the area of that semicircle. So the whole area of the garden is 47.04 added to 27.71. So that gives me 74.75. So how many boxes do we need? Well, each box can cover 12 meters squared. Okay, so if I need 74.75 meters squared covering, if I divide these two values through, that tells me how many boxes I need. Okay, and so we'll need 6.2 boxes. Okay, well, Carol cannot buy 6.2 boxes. She can either buy 6 boxes or 7 boxes. So she'll definitely need 7 boxes to have enough for the garden, and she'll have a little bit left over. Okay, so 7 boxes times by £4.99 per box, and so it will cost her £34.93, and that would be 5 marks for that question. Okay, so part B says that Carol finds out 1 box of fertilizer will cover more than 12 meters squared. Explain how it might affect the number of boxes she needs to buy. Well, she might need to buy less boxes depending on the coverage of each, and that would be enough for you to get that last mark in that question. If you wanted to, you could actually work out the minimum coverage she'd need for just have 6 boxes, and you could do that by doing the area, which you know, divide it by 6 boxes, and that would give you 12.45 meters squared. But that working out in the brackets there is optional. You don't need that for that last mark. The whole question there is worth 6 marks. Okay, question 22. So we've got a cycle track there. The track has got 2 straight sides, each of length 40. So that's 40, and that would be 40. And each end of the track is a semicircle with a radius 27. So that's a radius there. Okay. The diameter of each wheel of Ian's bike is 590 millimeters. So that's a different unit you're given here. This is meters, this is in millimeters. Ian's going to ride his bike around the track just once. Calculate how many revolutions each wheel of his bike will make. So how many times will this wheel turn round if it goes around the track exactly once? Okay, so in this question here, just be really careful of these units here. Okay, the way I'm going to tackle this question is I'm going to find the perimeter, okay, of this entire track, so the distance all the way around. Then I'm going to find the circumference of his wheel, okay, bearing in mind it's different units. Then I'm going to divide those through, okay, divide the perimeter by the circumference of his wheel to find the number of revolutions that his wheel makes, okay. And just remember, this says complete revolutions, okay. So let's underline the key information in that question there, okay. So let's find the perimeter of this. Well, the perimeter of this entire track is given by those straight sections in purple plus that section there in brown plus that section there in brown, and these two semicircles would actually join to make a circle. So I'm just going to put these together to make a circle. So the whole perimeter is going to be 40 add the circumference of that whole circle, which is pi d, and the diameter here, remember, is not 27. 27 is the radius, so the diameter is 54. So 40 add pi times 54, okay, and that would give me 249.65 meters. Okay, now because his wheel here is given in millimeters, I'm going to convert this unit into millimeters straight away. Okay, so let's convert it into centimeters by multiplying by 100, then turn it into millimeters by multiplying by 10. You can just multiply it by 1,000 in one step. That would give me 249,650 millimeters. It's obviously a big number, but that's in millimeters. So now, the next stage is I'm going to find the circumference of his wheel. The circumference of his wheel in millimeters is just pi d, same as what I used here, pi d. So it's pi times 590 millimeters, which is 1853. The number of revolutions is the whole perimeter, which I've worked out here, divided by the circumference of his wheel, which I've worked out here. So if I divide those through, because they're in the same common units now, I'd get the number of revolutions. So the number of revolutions is 134.6. Now, it does say how many complete revolutions, so that's not quite a complete revolution. That's 134 revolutions and a little bit left over. So I have to round this down to complete revolutions. So that would be 134 revs. And that whole question there is worth 5 marks. Okay, question 23. The diagram shows a semicircle drawn inside a rectangle. The semicircle has a diameter of 8. The rectangle is 8 by 4 centimeters. Work out the area of the shaded region. Give your answer correct to 3 significant figures. So in this question here, okay, to find the area of the shaded parts, I'm going to find the area of the rectangle, then I'm going to subtract from that the area of that semicircle. Okay, so the area of the rectangle is length times width, which is 8 times 4, which is 32. And the area of the semicircle, well, it's the area of a circle divided by 2. The area of a circle is pi r squared. I divide it by 2, and I use the radius of 4. Okay, so the radius is 4 here. Then I get 25.13. Now, when I subtract those through, I get 6.87 centimeters squared. Okay, that would be 4 marks for that question. Okay, question 24. I'm given an arc ABC, so that's this curved part here, and that's a quarter of a circle, okay, with a center O and a radius of 4.8. Okay, so it's like a quarter circle. Okay, but AC is a chord of the circle. Work out the area of the shaded segment. Work out the area of the shaded segment. So just this shaded part here, and giving an answer to correct to 3 significant figures. And this question is worth 3 marks. So for this question, to find the area of the shaded region, I'm going to find the area of a quarter circle, and I'm going to subtract from that this white region, that area of the triangle, and that would leave me with this grey shaded area. Okay, so that's how I'm going to do the question. So there's the important information underlined. Let's find the area of the quarter circle. Well, the area of a circle is given by pi times radius squared. A quarter of that is obviously divided by 4. Okay, so the radius is 4.8. I'll substitute that in, we've got 18.09. The area of the triangle, okay, area of a triangle here, is base times height, base times perpendicular height, divided by 2. The base is 4.8, perpendicular height is 4.8. Multiply them and divide by 2, I'll get 11.52. And if I subtract this entire quarter circle, subtract the triangle, I'm left with just this grey shaded region here. And that will give me 6.576. And to 3 significant figures, it's 6.58. So that whole question there is worth 3 marks. Okay, question 25. So the diagram shows a trapezium ABCD and 2 identical semicircles. So the semicircle has been cut out. Okay, the center of each semicircle is on DC. So these are true semicircles, and I've got to work out the area of the shaded region, giving my answer to correct to 3 significant figures for 4 marks. So in this question here, first of all, I'm going to find the area of this whole trapezium, okay, without the semicircles being cut out, so the area of the whole thing. Then I'm going to find the area of these 2 semicircles, and then I'm going to subtract those 2 values to give me the shaded region. Let's underline the key information. There it is. I'm also noting that 2 identical semicircles is actually 1 circle, so I'll use that later on. Let's first of all find the area of this trapezium. Well, the area of a trapezium is given as a formula by finding the sum of the 2 parallel sides. So these 2 sides are parallel. If I sum those together, and then I divide by 2, in other words, I'm finding the mean average of these 2 parallel sides, multiply by the distance between them, in other words the perpendicular height, okay, then I'll get the area. Okay, so 28 add 12 and then divide that by 2 and then multiply by the distance between them, I'll get 280. If you're unsure on where I got this formula from, look back at the section on area on my website mathsupgrade.co.uk and you'll get a topic booklet from there. The area of a circle is given by pi r squared. These two semicircles do form to give a circle. So let's just find the area of a circle which has got a radius of 3. The reason the radius is 3 is because the whole of this bottom base of the trapezium is 12. And each semicircle is obviously going to be diameter of half of 12, which is 6. But the area of a circle is given by pi times radius squared. So pi times 3 squared. 3 is the radius. That gives me 28.27. So that's the area of this whole white region here. To find the area of the grey shaded section, I can just do the area of the whole trapezium, 280, subtract 28.27, which gives me 251.7. So to 3 significant figures, that would be 252, and that would be 4 marks for that question. Okay, question 26. So here we're given a rectangle ABCD and also a circle. Okay, and the width of the rectangle is identical to the diameter of the circle, but we've got to find the percentage of the area of the rectangle that is shaded. So imagine this rectangle ABCD, what percentage of that is grey? Okay, give your answer correct for 1 decimal place. So in this question, okay, I'm going to underline the key information, and I'm going to tackle this question by finding the area of the rectangle, so this ABCD, this whole rectangle, the area of the semicircle, which has been cut out from the rectangle. If I subtract those two, I end up with a shaded region here, the shaded area, and the percentage is given by the area of the shaded region divided by the whole area of that original rectangle. Okay, and then obviously multiply that by 100. So let's find the area of the rectangle first of all. Well, area of a rectangle is given by length times width, 19 times 16, which is 304. The area of the semicircle is given by pi r squared, but then I have to divide it by 2 because it's a semicircle. So pi r squared divided by 2. Well, the radius here isn't 16. 16 is the diameter. The radius is 8. So pi r squared divided by 2 gives me 100.53. So the shaded region of this shape, the shaded region, is the area of the rectangle, subtract that area of the semicircle. So 304 subtract 100.53, which gives me 203.47. Now, I've got to give this as a percentage of the area of the rectangle. So here's the area of the shaded grey part, okay? And if I write that as a fraction of the area of the rectangle, okay, and then multiply by 100, that'll turn it into a percentage. So 203.47 divided by 304 multiplied by 100% will give me 66.93%. But to 1 decimal place would be 66.9. And that question there would be worth 4 marks. So question 27 has given me a circle and an equilateral triangle. One side of the equilateral triangle is the diameter of the circle. The circle's got a circumference of 44. Work out the area of the triangle. Okay, so to find the area of a triangle, I need the base and the height. Okay, well, I have got neither the base nor the height, but what I'm told is the circumference of the circle is 44. So from that circumference, I'm going to find the diameter of the circle, which is this distance here, which is therefore the base of that triangle. But I still need to find the height of the triangle. To find the height of the triangle, I can split this triangle into 2 equal pieces, okay, and therefore I've got a right angle triangle, and then I can use Pythagoras to find that perpendicular height there. So let's do that now. So first of all, let's use c equals pi d. Because I'm given circumference, I need to rearrange this to find the diameter. So let's divide both sides by pi, substitute in the circumference, and that leaves me with a diameter of 14.01. Now, like I stated, I'm going to split this triangle into half. There's a line of symmetry down there. Okay, and when I split it in half, since I know that the diameter of the circle is 14.01, so I know that this section here is 14.01. This diameter is 14.01. And then if I divide that by 2, okay, I know the base of this triangle, this short side here, which is 7.003. Now, since this triangle is equilateral, okay, and I know that the base is 14.01, I also know that this side here is 14.01 because it's equilateral. So now I know the hypotenuse in this right angle triangle, and I know the base of the right angle triangle. Using Pythagoras, I can find the height of this right angle triangle, since Pythagoras states that the sum of the squares on the two shorter sides is equal to the square on the hypotenuse on the longest side. I can rearrange that to find the height, which is one of the short sides, and that would give me 12.13. So using Pythagoras, the height here is 12.13. Now, the area of the triangle is given by base times height divided by 2. So if I substitute it into there, the base is 14.01, which is all the way across here. The height, which is 12.13, which I've just calculated, divide by 2, and I get 84.93. Three significant figures would be 84.9, and that would give you your 3 marks. So in this question here, I'm given a quarter circle of radius 15 centimeters. I'm also given another circle here, shape B, and I'm told that the area of A is 9 times the area of B. Show that the radius of B is 2.5 centimeters, and this question is worth 3 marks. So the way I'm going to tackle this question is I'm going to first of all find the area of A, bearing in mind it's a quarter of a circle. Then I'm going to find the area of B, given the information here. Then I'm going to use the fact that the area of a circle is pi r squared to find the radius of B. Okay, so let's do that now. So I've underlined the key information here. I'm also using just a letter for the radius of B. So I'm using the letter X. I'm not using the letter R because that might confuse us with the radius of A here. I'm just using the letter X. Okay, so that's what I need to work out. So first of all, the area of A. Well, since it's a quarter circle of radius 15, I can do pi r squared, but then divide it by 4 because it's a quarter of a circle. So that would give me 176.7. That's the area of A. Now the area of B, okay, well the area of A is 9 times greater than the area of B. So the area of B must be the area of A divided by 9, okay, because this is a lot smaller. So divide the area of A by 9, I'll get 19.63. Now, this is the area of B, but the area of B is also given by pi times radius squared for a circle. Well, since the radius I'm using is the letter X, I've got pi times X squared. If I then substitute in the area that I've just worked out, and then rearrange this formula to make the radius X the subject of the formula, I end up with 19.663 divided by pi, then square rooted, which gives me exactly 2.5. So that question there is worth 3 marks. Question 29. The diagram shows a square of ABCD, side 8, inside a circle, center O. So the corners of the square, the vertices, are just touching the edge of the circle here. Okay, work out the total area of the 4 shaded segments. So the total area of these 4 shaded parts here. Give your answer correct to 3 significant figures. Okay, so in this question here, I'm first of all going to use Pythagoras to find the radius of that circle. Okay, since I know that this is 8 and these two are equal lengths. I'm going to use Pythagoras there. Then I'm going to find the area of the square. I'm going to find the area of the circle since I've worked out the radius. Then I can use that to find the area of the shaded region. So let's do that now. So underlining the key information here. Okay. And I know that since this is a square, the diagonals of the square will always meet at 90 degrees. So here you've got a 90 degrees angle. So let's just draw this triangle here in this diagram here. So I need to find the radius of this circle. But because this circle is isosceles, because it's got two equal radii, I know that using Pythagoras, the sum of the squares on the two shorter sides is equal to the square on the hypotenuse. So radius squared plus radius squared is equal to 8 squared. Well, these radii are equal, so I can just collect like terms here. Then I can divide both sides by 2 to solve this equation, and then just square root, and that would give me the radius of 5.657. 5.657 is the radius. Now, I need that later on, but just before that, I'm going to find the area of this square. That's straightforward. It's just the length of the square squared, so that will be 64. Now let's find the area of the circle using that radius I found a moment ago. So the area of the circle is pi times radius squared, which is pi times 5.657, which gives me 100.5. Finally, to find the area of the shaded sections here, I can use the area of the circle and cut out the square. So the area of the circle, subtract the area of the square, 100.5 subtract 64, which would be 36.5 to 3 significant figures. So that whole question there is worth 5 marks. Question 30. So Hasmi walks once around a circle with diameter 80 meters. There are 8 points equally spaced on the circumference of the circle. In part A, I've got to work out the distance Hasmi walks between one point and the next, okay, which is for 2 marks. And then part B, 4 of the points are moved and has the mean distance that he walks between one point and the next point changed, giving a reason. So the whole question there is worth 3 marks. So let's do the first part now. Well, the distance is walked, okay, I can work that out if I find the circumference and divide it by the number of points around the circle. Okay, the circumference of the circle is given by c equals pi d. So if I use pi d, okay, pi times the diameter, so pi times 80, and then I divide that answer by the number of points I've got around the circle. So pi times 80 divided by 8 gives me 31.4 meters. So that's a distance that it walks between each point. 31.4, 31.4, 31.4. So that's that answer there for 2 marks. Okay, part B. Okay, so 4 of the points are moved as shown in the diagram below, and he walks around the circle again. Has the mean distance changed, okay, between one point and the next, giving a reason? Well, the mean distance is given by the total distance divided by the number of points. Okay, the total distance hasn't changed because it's the same circle. The number of points haven't changed because there's still 8 points around the circle. So therefore, okay, the mean distance is still exactly the same. Okay, so the answer is no. The mean distance is exactly the same. That whole question there is worth 3 marks. Okay, question 31. The diagram shows 3 identical circles inside a rectangle. Each circle touches the other 2 circles and the sides of the rectangle as shown in the diagram. The radius of each circle is 24 millimeters. Work out the area of the rectangle, give your answer correct to 3 significant figures. Okay, so this is quite a tough question. Okay, the way I'm going to approach this question is I'm going to draw on my diagram as much information as I can. Okay, and then I'm going to join these 3 points up to form a triangle. Okay, and then I'm going to use Pythagoras to work out parts of that triangle. So let's do that now. So As you can see on the diagram here, join the centers of the circles up. Okay, and because the radius of each circle is 24 millimeters, this distance here is 24 millimeters, and this distance here is 24 millimeters. This is 24 millimeters. Okay, so essentially I've got an equilateral triangle here, okay, with each side as being 48 millimeters. If I split that equilateral triangle down the middle, okay, then I end up with this right angle triangle here. I end up with 48 as the hypotenuse, and one of the short sides would be 24. But I don't know this perpendicular height of that triangle, so I don't know that perpendicular height there. If I can find that perpendicular height, okay, then I can find the area of this entire rectangle, okay, because I know the other length here. So using Pythagoras, I know that the square of this shorter side is the square of this longer side, subtract the square of this shorter side. So using that, I can find x as 41.57. The area, so that's 41.57. If I then substitute that into the here, I then know that the area of this entire rectangle is given by 24 as this part here, 24 as this radius here, 24 and 24. So this whole width of the rectangle is 96. Okay, and similarly here, I know that this radius is 24, and now know this distance here is being 41.57, and now this is 24. So if I now use these measurements to find the area of the rectangle, base times height, I get 8,598. And to three significant figures, that would be 8,600 millimeters squared. So that whole question there is worth 4 marks. Okay, question 32. So I'm given a region R, which is shown shaded in that diagram, and it's between those two concentric circles. And you've got the radius of the outer circle, which is 2n plus 6, and the inner circle's radius is n minus 1. And the area of that shaded region is greater than the area of a circle of radius n plus 13, where n is an integer. So find the lowest possible value of n, showing while you're working. So this question's worth 5 marks. It's a difficult question. Okay, but I'm going to start it off by first of all just labeling up those two radiuses. I'm going to label the radiuses as just R1 and R2 for now. Okay, and I'm going to for this statement here, okay, I'm going to say that the area of R is greater than pi r squared. So it's greater than pi r squared, where the radius is n plus 13. So if I square that radius, in other words, expand those brackets, I end up with that expression there. So the area of R is greater than that. So I'm going to need that later on. Okay, and I also know that the area of R is the area of this large circle, subtract the area of this white circle, because the white circle has been cut out. So if I write that as an expression, I can see that the area of that shaded region is the same as pi r1 squared minus pi r2 squared. If I substitute in those radiuses from this diagram, then I end up with that expression there. If I then factorize for pi, I end up with this expression here. Okay, so factorize for pi. So pi is now outside the brackets. If I now expand these brackets, so expand this double bracket here, so square the bracket, and if I square this bracket, I end up with this expression here. And just be careful with this subtraction here, because that will change the sign of everything inside the brackets here. If I then collect like terms, I end up with 3n squared add 26n. This is an add 26n because 24n subtract negative 2n gives me positive 26n, and 36 take away 1 gives me 35. So I've now got this expression up here, okay, as the area of R is greater than that, and I've got this expression here, okay. Using these two expressions, this is the area of R, this must be greater than that, so that must be greater than that, so that's where I've got that inequality from. So again, I need to solve this inequality. So to solve this inequality, I'm going to divide both sides by pi. Then I'm just simply going to use a balancing method to solve this. So I end up with 2n squared, which is greater than 134. Divide both sides by 2 and square root, and I end up with n is greater than the root of 67. Okay, so the root of 67, okay, is obviously going to be something slightly larger than 8. So n is an integer bigger than 8, and the next biggest integer after 8 is 9. So there's your 5 marks there for that question. That was a tough question, a lot of algebra there, but that is essentially how you do that question. Okay, in this booklet there were quite a few questions involving Pythagoras. Be sure to check out my videos on Pythagoras on my channel, and also check out the booklet which is on mathsupgrade.co.uk.